So number one, I will let you know. Oh, here he comes. All right. All right, just let him get in here so I can say that. Number one, I want to, this is acting really weird right now. It's incredibly big. Okay. So, Akul, are you here now, brother? There you are. Hi. Okay. So there's a couple of things that I want to talk about. The first thing is I will let you know when, but you guys have to bring back your textbooks. Remember those? So the Honors Algebra 2 textbooks, I see some of us already looking to see, where are they? Is it somewhere in my room under my bed? Is it in the mattress? Like, where is it? Okay. So that's going to be one of the first things. I will let you know what day or days you can actually return those to school so I can find that out. The second thing is I have a workout at 3 o'clock today. Who is going to be in attendance with the workout? Yeah, Kyle. See, thank you for being a constant. Thank goodness. Anybody else? I got some other people, Kyle. It's not just going to be you and me. Nobody else from this class is coming. The only reason why Aiden isn't coming because he broke his toe, and I know that Riley, you probably have to work out someplace else and stuff. So, Josh, you're not coming? You're on mute, bro. I can't hear you.
I'm sorry. I was just gonna try to finish my work because I have a lot to do tomorrow. I was gonna stay in today.
Okay. That little half hour give you a little energy, just so you know. Just, consider it. Okay. I said 1, 2. Oh, and then the third thing is we're not going to have like a final exam in here. We're going to have a final reflection. So I will have something posted for you on Tuesday on what exactly that looks like. So you're going to write almost like a reflection piece to say, here are some things that I really loved, some things I really liked learning in this class. Here are some things that gave me a hard time, and here's why. I enjoyed being in class in school because when I'm out of school, here's what I struggled with, blah, blah, blah. So, the more reflective and the more effort you put into it, the better your grade. So if you give me a half-assed effort, you get a half-assed grade. So there you go. Okay? Yeah? I still feel like there are people missing. I don't know why, but I just do. But anyway, we're going to move on. So one of the things I want to talk about is that number 13 problem that we had when we were solving the equations and whatnot. And I have to tell you, I legitimately enjoyed all the different ways that you guys went about solving it. So hold on, it was this one here. And by the way, there's a couple of you who did not hand in your homework. You need to get it into me. You know who you are because I already checked. It's not a 4. So, okay. So we have 6 to the x minus 3, I believe it was, is equal to, you were asked to solve this equation, 10 to the 2x plus 5. So the cool thing is some of us, I love, some of you found a same base. Some of you took log base 10 on both sides. Some of you took the natural log of both sides. I want to ask, I think it was, I actually wrote it down. Akul, Aiden, and Hillary. How did you guys go about solving this one? So for you guys, like you rewrote it. I'm just curious on what you did. I was like, wait a minute, what is this? I want them to share that. So it was either Aiden, Akul, and Hillary. So whoever wants to take the reins here and show us what they did and why, I would love that.
I wrote the 10 as 6 to a power. So just like.
So how did you write it? So if you want to just dictate it to me and I'll write it.
Oh yeah. So I just wrote the same thing on the left side.
Okay.
And then for the 10, I wrote 6 to the log base 6 of 10. So
you wrote 6 to the log base 6 of 10?
Yeah.
You're saying that this is equal to 10?
Yeah.
It is? Yeah. You're saying, wait a minute, how is this equal to 10? How is that possible?
Because it's like log base 6 of 10 means what number do you raise 6 to so it equals 10? And if you raise 6 to that number, then it has to.
Right. That's beautiful. So does everybody see that? Like, so check it out. So he wrote 10 as log base 6 of 10 to the 10th power. Because if you do look at this, 10 to the 6th is, if you rewrite this in exponential form, you do get 6 to the 10 is equal to 6 to the 10, right? So you wrote it out that way. Aiden, I believe you did the same thing too. Is that correct?
Yeah.
Yeah, you did the same thing too, which I thought was clever. So, and then again, throw parentheses around that. So 6, so this is the same thing as 10, and you rewrote it like that, which I thought was absolutely cool. And then you were able to set them equal to each other where you had x minus 3 was equal to log base 6 of 10 times 2x plus 5, right? And then you could just do whatever algebra you needed to do. Yeah? Yes? Hello?
Yeah.
Yeah.
Get it?
Yeah.
Okay. And most of us eventually got to this point anyway. What I like too was if you have, again, 6 to the x minus 3 is equal to 10 to the 2x plus 5. What some of you also did is you took the log of both sides because you watched that video I showed you, right? And you did log of base 10 of 10 to the 2x plus 5. Because if you remember, this is base 10. We all know that if I don't write anything in there, we assume it's base 10. If you're with me, say you're totally with me. Hello? Can you guys be a little more interactive? Help. Yes? Okay. And now if we go back to this log property, if you remember, like log base a of x to the nth power, we were able to write it as n times log base a of x. And this one log property you can use in however favor you want to, right? So now if we took the log of both sides, then we can employ this power where we could take this and bring it down. And we have x minus 3 times log of 6 is equal to 2x plus 5 times log of 10. By the way, I just put my little 10 in here. Oh, little 10 here. What is the log base 10 of 10 equal?
1.
Yes, it does. Log base 10 of 10 is equal to 1 because, again, if you go back to, log base 10 of 10 and you set it equal to x, and you write that in exponential form, you get 10 to the x equals 10, so x has to equal 1. So we now know that this is equal to 1. And again, we could go ahead and solve this whole thing through and call it a day. Like, again, you could just distribute log of 6 to both of these. So you would have, log of 6 times x minus 3 times log of 6 is equal to 2x plus 5. And then get your x's to one side. I don't know why this thing is so crooked. All right, thank you for being stable. And then move the 2x over. So you have log of 6x minus 2x is equal to 5 plus 3 log of 6. And then you can factor out an x here. So you have log of 6 minus 2 is equal to 5 plus 3 log of 6. And then x is equal to this divided by this. So this is log of, let me just squeeze that in as tight as I can, minus 2, which I think was about -6. Was that right, guys? It was about -6?
Yeah.
Yeah. Okay. So what I wanted to, so one of the things I really like too is that somebody else also said, I'm going to rewrite 6 and 2 in terms of the same base. So you estimated 6 is 2 to some power, 10 is 2 to some power. So that way you had the same basis so you could set the exponents equal to each other. So I just want to say, I really enjoyed all the different ways that you guys went about solving this. And it was so clever. And some people actually, someone, I think, I don't know who it was, it might've been Ashan in the last class, 10 to the 2x plus 5. Instead of doing the log base 10 of both sides, he did the natural log of both sides. He did the ln of this, 2 to x, because remember, what you do to one side, you do to the other. Again, if you bring that exponent down, you have the natural log of 6 is equal to 2x plus 5 times the natural log of 10. What base is that, by the way, for the natural log?
E.
It's e. Very good. So that's beautiful. So when you get it all said and done, it's all going to work out. So let's go. Aiden's having an issue getting in here. So let's go back and just do a quick review of our log properties. If I have log base a of x plus log base a of y, how can I write that? Can somebody tell me what it is? Or if I have log base a of x minus log base a of y, how can I write that?
A of x plus log base a y is log base a of x times y.
Very good. So that means, and this one is going to be the log of a of
X over
x
y.
over y. What can't y equal, folks?
0.
0, thank you. Okay. And then if you remember, log base a of x to the nth power is equal to n times log base a of x. And then if you remember, when we do a change of base, we can write this as log base b of x over log base b of a. So, and this was something that I showed Kyle or somebody else who doesn't have it. And I actually did a proof. If you remember, if you watch my video, I actually proved all of these, right? There was videos where I proved why this is true, a video why I proved this is true. They're on the same video. And then together I proved why these two are actually true. So what I'm telling you is that if you have log base 2 of 3, you can write as log of 3 over log of 2, where that's what base, folks? What base are these in?
10.
10, thank you. So these are in base 10, so you can write that. And the reason why we would typically want to write them in that is because our calculators actually have it. So if we, and you could even write this as, by the way, as the natural log of 3 over the natural log of 2, because again, we would be assuming that the base is
E.
You could also write it as, just so long as your base is the same, give me a number.
4.
4.
Sure. You can write this as log base 4 of 3 over log base 4 of 2. So if you were to type this into your calculator, type this into your calculator, type that into your calculator, and that one, you are guaranteed you are going to get the same answer. Now, what if I have log base 2 of 2? What does that equal? What is log base 2 of 1 equal to? Again, you can write it in take log form and write it in exponential form. Because again, this is what we're doing. We're putting our clever hats on.
Log base 2 of 1 is 0.
It is 0. Very good. So this is 0. Very nice. And then this one is?
1.
It's 1. Because again, the reason why is because if you have log base 2 of 2, you can set that equal to x. That should be a 2 there. And when you write it in exponential form, you get 2 to the x equals 2. So x has to equal 1. And then over here, the same thing here, 2 to the x has to equal 1, so x would be equal to 0. So that's why that's always true. So I want to go back to, I want to show you something uber cool. Okay. Let's say we don't have, we don't have a log button on our calculators. Let's say that somebody gave the things to us that all we have on our calculators is addition, subtraction, multiplication, division. Those are the only 4 operations we have. You remember those cute little calculators you had when you were kids? Those little ooty cutie patooties? So just imagine that, you know, your calculator died. This monster's like, I'm dead. And then you only have one that does simple operations. So let's say that we want to evaluate all of these things given this information here. So in other words, I know that log base 5 of 2 is equal to this and log base 5 of 7 is equal to this. I want to use this knowledge right here to help me go ahead and evaluate these with just using a simple calculator. So if I look at, and you're employing your laws of exponents, your laws of logs, the whole 9 yards. So when you look at letter A, and letter A is log base 5 of 32. And the only thing you're allowed to use is this right over here and any of your laws of logs, right? Or your laws of exponents. What do you think you want to do? How do you think you would start to approach this?
Maybe put it in like exponential form.
Okay, so before we put it in exponential form, I like what you're saying. Let me say this. Can you rewrite anything in this expression? Like, in other words, is another way that you can rewrite 32.
You can write it 2 to the 5th.
Yes, Katie, I like it. You can write it as 2 to the 5th. So check this out. So right over here, I can rewrite this as log base 5 of 2 to the 5th. What can I do now? What can I do now?
Do 5 times log.
Yes, because we can use that beautiful property, this luscious one. And remember, it's all about what we want to use in our favor, that when we have log base a of x to the nth power, we can write as n times log base a of x. So Lena's like, why don't, or was it Katie or Lena? Who was it?
Lena.
Lena, I thought it was. Okay. Lena's like, bring the 5 down because we can use that property. So now we have 5 times log base 5 of 2. So now we can just go ahead and substitute in what we need to substitute in, right? And now we can call it a day. I don't know why I wrote that so sloppy. So it's just going to be 5 times that. So again, we took the 32 and we wrote it in an x as an exponent because we want to get it so we can make things look like this. So 5 times log of 5 of 2. So we're just going to take 0.43 blah blah and multiply it by 5. How would you do this one when you have log base 5 of 14? And again, remember, you are cleverly using your laws of exponents or your laws of logarithms to do what it is that you need to do. Anybody have an idea?
You can change it to 14 to 7 times 2. And
Yes.
then you can put them up into 2 logs.
Let's start here. Good. So Akul's like, change it to 2 times 7. 14 is equal to 2 times 7, right? And then what can you do from there?
You can split it up into like log.
By doing log of log
log
base,
base 5 of 2.
plus log base 5 of 7. So do you see how we're starting to employ those log properties as we're doing this? You guys all see that? Okay. I'm going to add an F. So you guys are going to do, so if we were to do, you're going to do C, D, and E for me, and then I'm going to throw F in there just for fun, and I'm going to go log base. Don't worry about what I'm doing, but start working on C, D, and E, and then I'll throw F up here, okay? Okay. So remember, you're using your laws of logs. And there's so many different laws that you can use, which is kind of great. How we doing, gang?
Good.
Good. When you think you've got it, right? When you think you've got it and you think you're ready, if you're ready, if you're like, okay, I'm done, I'll go do F, you can go ahead and start writing on here and writing the answer. So whoever wants to do C can do C, whoever wants to do D can do D. Or actually, you know what? We'll do it together because I want to do something else after this. So let me know when you guys are ready to go, and then I'll just have you dictate to me what I want you to say, okay? Okay. And then I can just write it in.
Wait, so are we just annotating on the?
We don't have to annotate. I will just tell me what you want me to write because it'll be faster. The next thing I'm going to have you guys do, you'll actually annotate for me, okay? All right, so who wants to give me a shot at letter C?
I could do it.
Okay, let's do it.
So you could do log base 5 of 2 to the negative 1,
Okay, I love it. Uh-huh.
and you just do -1 times log base 5 of 2.
Beautiful. Did anybody do something different? Did anybody do something different?
I did log base 5 of 1 minus log base 5 of 2, and I know log base 5 of 1 is 0, so it's just negative log base 5 of 2.
Isn't that delicious, right? I love that you both went about it a different way. So Aaron's like, I'm going to write this as 2 to the negative 1. bring that down, blah, blah, blah. You're using the subtraction property, and they both work out, which is great because, yes, that does come out to 0. And I'm going to say the same thing happens for letter D. Would everybody agree the same thing will happen for letter D? Okay. How about letter E? Who wants to take a shot at letter E? What's the first thing you would want to rewrite this as?
You can rewrite it as 7 over, or log base 5, 7 over 2.
Good. And then write it as?
Log base 5 of 7 minus log base 5 of 2.
You know I'm enjoying this. Okay. Good. On the last one, what's the first thing I'm going to do here? Dennis, what would I do first? We can't hear you, guy. You're on mute.
So you can convert 8 to 2 cubed,
Yep.
and then you can put over 7 squared.
Love it. Go ahead. And then what did you do from there, friend?
And then after that, I converted, I just did, using the log rules, I did log 5 2 cubed minus log 5 7 squared.
And then what'd you do after that?
And then using the, like the third log, like the one above, you can convert that to 3 times log 5 2, log base 5 2 minus 2 times log base 5 7.
I love it. I absolutely love it. I think that's great. So yeah, bringing that 2 down, log base 5 of 7. And then you would obviously just substitute those values in, right? Okay,
Yeah.
So I'm going to say, keep going, keep going. Here you go. You guys knock these out for me. We have a few minutes. So now we have a new set of logs. So we have log base 2 of 5 is equal to this, and log base 2 of 3 is equal to this. So how are we going to go about doing that? And when you are done, jump in and start annotating and start drawing on there, okay? Just getting clever. I love these because what it does is you're getting really clever with the use of laws of logs and laws of exponents. Like you're literally incorporating the two of them and being like, hey, look at what we can do. Okay. I have so many. I live in the land of Post-its. I have Post-its all over my walls and on my desk. Again, when you're ready, if you think you're done, just jump in there and start writing on that, and then we'll finalize and call it a day, my friends. It's so hard to do when you don't have a pen. Whoever's writing in black, though, do you have a pen, or are you writing in pen?
No.
Who's that? Who's doing that one in black? Does somebody have a pen they actually use?
No.
You're just so good at this?
I guess.
That means you got some strong hands there. That's good. Your fingers are strong. I'm very impressed. Okay, I love it. And if we were to do all the calculations and all that, did anybody do this one differently? Did anybody do this one differently? No? What I saw last class, I'll show you what I saw last class. On the last class, somebody went ahead and did log base 2 of 15 times 3, did that first, and then did log base 2 of 15 plus log base 2 of 3, and then changed this to 3 times 5, and then had log base 2 of 5 plus log base 2 of 3 plus log base 2 of 3. So this is going to give you the same thing as this. And it should make sense that if I have a log base 2 of 3 and Max has a log base 2 of 3, together we have 2 of them. So I think what's really nice is that this is incorporating all your little laws. This is why I want to show it to you guys, because I thought it was kind of fun. And yeah, so I just enjoy it immensely. And you know, I think that's a neat way to really utilize logs, in addition to how we solve problems when we were doing like Newton's law of cooling with the cocoa problems and stuff like that. So if you guys don't have any questions, I just want to bid you a phenomenal day. And yeah, we'll just kind of take it from there. And yeah, do you guys have any questions for me?
No.
No? Okay. It's a weird